All right, in this short video, I will demonstrate logarithmic differentiation. I'll probably give two examples, one with rational function, the other one with polynomial. Logarithmic differentiation is a very powerful method of differentiation where we use a lot of times when you have either rational expression or rational function or polynomial that has involved a lot of expressions that's not easy to do with quotient rule or with product rule. Not easy. You can always do quotient rule and product rule, but the logarithmic differentiation makes it easy. All right. So logarithmic differentiation. So the first example, example one, I'm going to say find f prime of x. Find f prime of x if f of x equals, let's say, 3x plus 4 to the power of 5 over x squared plus 1 to the power of 4. So you can see this is a rational function, and I can use quotient rule or even product rule if I put the denominator to the numerator by putting -4 as the exponent. I could do that, but logarithmic differentiation will make it easy. To make things easier again, I will put, instead of f of x, I will just change it to y. So I will start with y equals 3x plus 4 to the power of 5 over x squared plus 1 to the power of 4. I'm just rewriting it, and then I take the natural log of both sides, which means base e. The natural log of y equals 5 times the natural log of 3x plus 4 minus, remember, the logarithm of the quotient is the difference of the logarithms, so 4 times the natural log of x squared plus 1. I have applied two rules of logarithms, at least in this case. One is exponent becomes coefficient in terms of the logarithm, and also like I said earlier, the quotient becomes the difference. Those are the two rules we should remember. Now we differentiate both sides. So remember, y is a function of x. So when I differentiate, I will get 1 over y for the log, but then I will have y prime because y is a function of x. When I differentiate natural log of 3x plus 4, the natural log gives me 1 over whatever I call it the baby function, but then I have 5 times. So 5 divided by 3x plus 4, then the derivative of this guy, which will give me 3, minus 4 over this x squared plus 1, but the derivative of this guy gives me 2x by power rule. Okay, so therefore, if I do it one more time, 1 over y prime equals 15 over 3x plus 4 minus 8x over x squared plus 1. Okay? If I multiply both sides by y, technical problem, okay. I had 1 over y prime equals 15 over 3x plus 4 minus 8x over x squared plus 1. If I take this one here, take this one here, this will be 1 over y times y prime equals 15x squared plus 15 minus I can just do this one as 24x squared minus 32x divided by 3x plus 4 times x squared plus 1. I can now combine like terms. 15x squared minus 24 x squared is negative 9x squared. So that's 1 over y. Y prime equals negative 9x squared minus 32x plus 15 over 3x plus 4 times x squared plus 1. Okay, so if I multiply both sides by y, so that's solving for y prime basically. So therefore, I'm going to put it here, y prime equals y times this whole expression, negative 9x squared minus 32x plus 15 over 3x plus 4 times x squared plus 1. But remember what y was. Y is this original expression basically here. So therefore y prime, which is the same as f prime of x by the way, is going to be, so this will be, I have 3x plus 4 to the power of 5 divided by 3x plus 4. So there will be 1 is missing, so that's going to be 3x plus 4 to the power of 4. But the denominator adds 1, so that's going to give me x squared plus 1 to the power of 4 plus 1 to the power of 5. And there's a little bit of algebra here. And then, of course, negative 9x squared minus 32x plus 15. Sorry. So that's my y prime, which if I go back to my original notation f, I would say therefore f prime of x will be the same as 3x plus 4 to the power of 4 over x squared plus 1 to the power of 5. And in the numerator, I have a polynomial of degree 2, 9x squared minus 32x plus 15. Well, this is not going to be factorable, so that will be my last answer in this case. So this is when you have rational function. I can also use multiplication, polynomial function instead, sorry. If I do polynomial function, I'm going to just consider y, example 2, y equals, instead of saying g of x or just f of x, I'm going to say y. Y equals x squared plus 1 to the power of 4 times 3x plus 4 to the power of 5, let's say. Well, if I take the natural log of y, this will be 4 times the natural log of x squared plus 1 plus, remember, when I take the natural log of the product, it becomes a sum, so 5 times the natural log of 3x plus 4. Remember, this is applying the background knowledge of the rules of logarithm. So that's going to be natural log of y. Well, I really can differentiate both sides now. So that's going to be 1 over y prime equals 4 over x squared plus 1. The derivative of the baby, which is x squared plus 1, gives me 2x, like I said earlier. Then this one would be 5 over 3x plus 4, but the derivative of 3x plus 4, which is the baby, will give me 3. So therefore, I have 1 over y prime equals 8x over x squared plus 1 plus 15 over 3x plus 4. If I take the LCD again, I get this as 1 over y prime equals, so that's going to be 24 x squared well, I don't think I will have enough space, so I'm gonna put it somewhere here. 24x squared plus 32x plus 15x squared plus 15 times 1 is 15 over the product of these two. I'm just taking the LCD. 3x plus 4. That will be the same as 1 over y prime. It's okay if I put it on the other side, it's fine. So if I combine like terms, so 24x squared plus 15x squared is 39x squared. So that's 39x squared plus 32x plus 15 times y. So let me see, times y over x squared plus 1 times 3x plus 4. That will be my y prime. Okay, that will be my y prime. I'm going to replace my y by the original function, which is right here. So therefore, y prime, which is also, by the way, denoted as dy dx, if you wanted to do that, it's going to be x squared plus 1 to the power of 4 times 3x plus 4 to the power of 5 times 39x squared plus 32x plus 15, I'm sorry, I'm all over, divided by x squared plus 1 times 3x plus 4. Can reduce 1, this will give me 4, 1, this will give me 3. So therefore, y prime equals x squared plus 1 cubed. These guys are gone basically. 3x plus 4 cubed. And then of course 3x squared plus 32x plus 50. I hope I did not complicate it by using the logarithmic differentiation. Of course, product rule would not be easier than this. It would be even more complicated. And remember, if you were to be asked to do y double prime, it would be much easier to simplify it this way. You don't want to keep this big junk expression if you follow the product rule. So this logarithmic differentiation is a really powerful way of differentiating. All right, I hope you would like this, and if you do, just give it thumbs up. Also, if you have any question or any comment, you can also write in the comment section. All right, thank you. Bye.